let's say you have two paths. One with distance, once again, distances D1 and D2, both with unit amplitude. So at the receiver, they combine as we would have, okay, the first path is, so the transmitter sends sine 2 pi ft. The receiver, so the transmit phase is 0. Or actually, you can argue that the transmit phase is 2 pi ft. The receiver, we see from the first path, sine 2 pi ft plus 2 pi f d1 over c plus sine 2 pi ft plus 2 pi f d2 over c. And this taken together is equation 2 in your notes. Okay, here's a handy trig identity. Sine A plus sine B. Anybody?
2 sine A, sine B.
Not really.
So,
Sine A, sine
2 sine
B.
cos.
Sine A cos B cos.
Okay.
2 sine cos.
Yeah, 2 sine cos. 2 sine A plus B over 2. This is the particular form that I'm looking for, is the sum and difference form. 2 sine A plus B over 2 cos A minus B over 2. Okay, so equation 2 becomes equation 3. We have sine A plus sine B. So we end up with 2 sine, okay, what's A plus B? We would have 4 pi ft plus 2 pi f d1 over c plus 2 pi f d2 over c divided by 2. So I'm going to write this as 2 pi f t. Actually, I'm going to write it as 2 pi f t plus pi f d1 plus d2 over c times cos. Okay, what do I have over here? I now have A minus B. So I have 2 pi ft minus 2 pi ft, which is 0. 2 pi f d1 over c minus 2 pi f d2 over c, which is all divided by 2, so that's pi f d1 minus d2 over c. Okay, so this is the oscillating term. this you can think of as the interference term. This is the term that decides whether the two paths constructively or destructively interfere. So, what the maximum value of cos can go anywhere between 1 and -1. If cos is -1, if this is -1, that means both signals constructively interfere, but they're 180 degrees out of phase with what you started with, which is fine. They're still constructively interfering. I just want to point out this extra phase term over here. In practice, we're going to ignore that. As long as this thing is oscillating, what you can do, there's various kinds of hardware you can use to lock onto an unknown phase. One of them, a popular one, is called the phase lock loop. So generally, what will happen is when you demodulate, you will synchronize your demodulator to this phase term, and then it'll be as though you're sort of removing that. This is the term you can't remove. This is multiplicative, and it will have a constant amplitude between +1 and -1. And the trouble is, it can be 0. So if these signals completely constructively interfere, so let's say the distance d1 and d2 are the same. If those distances are the same, then what is cos? Well, okay, if those distances are the same, this is 0. What's cos 0? 1. So therefore I get 2 times sine, whereas I started out with sine and sine. So that makes sense. They're basically both components are contributing to what I receive. So I get basically a signal boost. The worst case scenario is when this is 0. When is this 0? When's cos 0? Cos is 0 when it's pi/2, when the argument is pi/2. So that will happen if d1 minus d2 is equal to c over 2f. C over 2f, I think. Anyway, if that happens, this is 0, so 0 times this is 0, so you'll get complete destructive interference, and that will go away. Okay, the effect of fading. This is fading. This is basically, I call this the interference term. I may as well call it the fading term. So that's what fading is all about. The effect of the fading term is possibly to diminish the signal to nothing. So it's possible for this to completely wipe out the signal. Okay, that's all I have time to talk about today. We'll pick it up from there on Tuesday. Any questions? Okay, see you Tuesday.